with more of the number theory stuff. So, do you know what this means if you put that? Oh, I guess it's saying it up there, huh? 5 factorial or 4 factorial, as the case may be, it means 4. And you're just like really excited about it. No, I'm sorry. It means all the way down to 1. 4, 3, 2, 1. All multiplied together, which is what, 24? So factorial, and if you've ever seen that before, when you have a number with a factorial, it means multiply all the way down to 1. So the question is, right there, so question A, 4 factorial straight line 30, that means 4 factorial goes into 30, right? Remember those straight lines means divides into? It's like the straight line for a long division. So we're saying, does 4 factorial divide into 30? Evenly. Does it go in there evenly with no remainder? Is what we mean. What's the answer? Yes or no? Yay or nay? No, it doesn't, because we just saw 4 factorial is 24. 24 doesn't go in. I mean, it goes in once, but it has a remainder of 6, huh? We're trying to go in evenly with no remainder. So no is the answer. False. False would be the answer to that one. But you know what I'd like to do is not just look and go, okay, yeah, 24 doesn't go into 30, just doesn't go in. I'd like to think about why, so that we can answer really big and really hard questions. What have you noticed? What has enabled us to do hard things easily? It's been primes. It's been thinking about the guts of a number, right? What's inside of it. So what is it that's inside of a 24 that makes it not go into a 30? Let's see what's in a 24. 4 times 6, 2 times 2, 2 times 3. What's in a 30? 5 times 6, 2 times 3. Okay, so from the prime level, here's the primes of a 24. Here's the primes of a 30. Remember, one number goes into the other number if all his primes are in there. So what's the problem? Why doesn't 24 go into 30? 24's got 3 2's. 30's only got 1 2. That's the problem. The 3 will go in, right? It's got 3, 3. That's not a problem. The problem is the 24 has 3 2's. It's not going to go into 30. If we took 30 and we multiplied it by 2 more 2's, then it would have 3 2's. Then 24 could go in. I don't even need to know what that number is. I just know it's true because I'm thinking about primes. You tracking with me? Basically, one number goes into another if all his primes are in there. If it's actually in there. So in other words, if the 30 is 5 times 2 times 3, and I put on 2 more 2's, that would be what? 5, 2, 3, and 2 more 2's. See, there would be the 3 2's, and there would be the 3. He would have the whole 24 inside of him, wouldn't he? Do you see that? I don't even know what that number is. What number is that? 4 times 30? 120. Does 24 go into 120? Yeah. You can check it on your calculator. 5 times perfectly. 5 times perfectly, because that's the extra prime. See how this stuff's all connected? It's all about primes, isn't it? All right, let's try the next part. Probably overdoing that particular part A there. How about part B? Part B says 80 goes into 25 factorial. True or false? So how are we going to answer this question? Hey, what if you guys have a calculator with you? What is 20? How big do you think 25 factorial? Before we go, let's guess that. Well, how big do you think 25 factorial is? Is it bigger than a million? Think it's bigger than a billion? Think it's bigger than the national debt, like trillions? Or is that just like crazy? This is like not that big. Well, let's see. You got it? What's 25 factorial? Somebody got it for me? Certainly don't know it off the top of my head. No way. Somebody got it? Can I borrow a calculator if you're not sure? So, where's the factorial button? It's on different places and different calculators. You know, you're old enough I can hardly see it anymore. I can't see it on yours. Oh, it's under the PRB key. I remember this calculator. There it is. Yeah. So yeah, I can show you on your calculator. On yours, it's under the PRB. So 25, and you get PRB, and you go down, there's an exclamation point. It's different on all the calculators. So, oh my goodness, there it is. It's bigger than even I was thinking. So what I got is 1.551121004, and then it's got this times 10 to the 25th. Is that true? Am I reading that right? Yeah. So that's the times 10 to the 25th. Yeah. So what does that mean? What is this 1.55 whatever with this 10 to the 25th? Joe, that's scientific notation. Have you seen that before? It's scientific notation. What does it mean? What does that 10 to the 25th thing mean? Move the decimal right 25 places. I mean, the decimal doesn't really belong here. It's just put there artificially. 25. This number tells you where to move the decimal in actuality. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. I've only moved 9 places. I've got a whole bunch more. And those are going to be more and more and more and more digits. This number is crazy big. I mean, it makes the national debt look like pennies. It's like millions of national debts, you realize. So it's crazy big. Just 25 factorial is that big. So we don't want to do the problem this way, do we? Even our calculator really is not going to be good at answering this question. So how should we answer the question? Primes, right? I just wanted to show you that even the calculator can't really handle this. Let's just think about primes. If you want to know if one number goes into another, find out if his primes are in there. Let's break down 80. What's in an 80? 8 times 10, 2 times 4, 2 times 2, 10 is 2 times 5. So when you have it all, what do you got? You got 2 to the 4th times 5. That's the guts of an 80. 2 to the 4th times 5. Good so far? Now let's break down the 25 factorial. What all is in there? Well, it starts at 25, and then 24, and then 23, and then 22, 21, and it just keeps on going, right? I'm going to run out of room in a hurry. I was going to go dot, dot, dot. It's just all those numbers multiplied, right? 25, those dots mean times. 25 times 24 times 20. Anyway, so the question for us, does 80 go in there? Well, are all these pieces in there? Are there 4 2s and a 5 somewhere in all those numbers? For sure. There's way more than that. You see what I mean? 4 2s and a 5. Well, first off, here's a couple of 5s right away in 25, huh? Now, do we have 4 2s? Oh, we got tons of 2s. 24 is 4 times 6, which is 2 times 2, 2 times... There's already 3 2s just in the 24. How about the 22? He's got another 2. We've already got our 4 2s and tons more to spare. Does 80 go in there? Absolutely, easily. All his parts are in there. Does that make sense how we answer the question? We don't need technology. We don't need to know what the gigantic 25 factorial trillions number is. We just break it down and see if the pieces are in there. Want to try C? Does 15 go into 10 factorial? Let's try question C. Does 15 go into 10 factorial? So, right, the 10 factorial, 10 is 10 times 9 times 8 times 8, etc. All the way down to 1. See if 15 goes in there. Does 15 go into 10 factorial? We'll go to a fresh screen here.
So if all parts are inside of it on X?
That's the rule, yeah. So, X divides into Y if all the primes in X, are also found in Y, then it's true. Does that make sense? To answer your question? Do you want one more time?
I mean, I get it. Just I don't know what makes it even. How does it make it?
What's that?
How it comes out evenly.
Yeah, so think about it. Well, here, I'll leave that up for a second. Does 2 times 3 go into 2 times 3 times 5? For sure. This is 6. This is 6 times 5, 30. Right? How many times does 6 go into 30? 5 times. See, it's the other number. Because 2, 3, because what is this number here? This is 2, 3, 5 times. So does 2, 3 go in there? Yeah. See, whenever it's found in there, it's got to go in there evenly, whatever the other numbers are, amount of times. Because this number here is 5 2 3s. So does 2, 3 go in there perfectly, evenly with no remainder? Yeah, it goes in there perfectly 5 times. Get the idea? What if we had more? What if we say, well, okay, yeah, but does 2, 3 go into 2, 3, 5, 7? Yeah, because what is this number here? It's 2, 3 times 35. It's 35 2, 3s. Exactly 35 2, 3s, isn't it? So this will go into that 35 times. It's making sense why it goes in evenly? If its pieces are found in there, it's got to go in evenly with no remainder. So how about C? Let's see. Whoops, that's not C. Did I get C? Yeah, so C, does 15 go into 10 factorial? Well, what are the pieces in a 15? 3 and 5. Are those pieces found over here in 10 factorial? Can you find a 3 and a 5? Well, yeah, there's a 3, there's a 5, and there's lots of other stuff too. Yeah, so this number on the right is a bunch of things multiplied by 3 and 5. So 3 and 5 has to go in there perfectly, evenly. Yes, it's true. How about D? D says, does 48 go into 6 factorial? So try breaking apart the 48, and then look at the 6 factorial, break apart the primes on both sides. See if it goes in there. Okay, so what's in a 48? Use your calculator if you want to, need to. Break it all the way down. So there's a 48. And what's in 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. And so what are all the pieces? And basically, do we have, 1, 2, 3, 4 2s and a 3? That's what we're asking, huh? 48, the guts of a 48 is 4 2s and a 3. That's what makes a 48. So over here, do we have 4 2s and 1 3? Do we have all that? Do you see? Tell me where are the 4 2s? Are there 4 2s there? The 6 has a 2 sitting in him. There's a direct 2, and the 4 has 2 more. There's 4 2s. Did you track with all that? Right? So I'm breaking all these numbers down also. Breaking them apart, finding out what's in there. There's a 2, there's 2 2s, there's another 2, that's 4 2s. So 4 2s are in there. And also there's a 3, huh? Well, and we already had this one. We have plenty of 3s. So yeah, it's got the stuff. So it's true. It's going in there. Good so far? Questions on that? All right, I'm going to keep moving. We're still on number 1. How about E? Does 2 to the 60th go into 100 factorial? 2 to the 60th. No mystery about that. That's 62s, isn't it? 62s. So what do you think? Over here in the 100 factorial, are there 62s? Are you sure? Or you just feel like there got to be? Yeah, I'd rather not write them all out, huh? You too, I'm sure. We're all feeling like we'd rather not. Let's just start though. 98, 97, 96, 95, 94, 93. Whoop, it's not 93. Etc., etc. Getting sloppy already. There's a 5 here. Anyway, if you just did that all the way down to 1, that's what 100 factorial is. Would you find 62s? What do you think? We got to be sure here. If your life depended on it, you get one chance, one answer, yay or nay. Could you come to a point where you're 100% sure? Math is always about being 100% sure because of logic, not because of warm, fuzzy feelings. Can somebody give me a good reason, like a convincing reason, that would convince everybody else that it's true or it's false? Either way. How do we know, yes or no, that there are for sure or for sure not 62s in there? Nobody sure? Nobody would bet their life on this? Yeah.
I would say it's true because if there's the 100 factorial, we know half of it is even, so that's guaranteed 52 already. And then there's numbers like 4, 8.
Let me hold you right there. Beautiful thinking. Did everybody catch that? She's saying, well, look, there's 100 numbers and every other number has a 2. Right? Every even number has a 2, and there's 50 of those, right? Like 100, it's got at least 1 2 in him. 98. Right? 96, 94, 92, etc. Half the numbers are even. So they got a 2. So there's 50 2s already. And then from there?
And then there's other numbers like 2, 8, 16, 32, where there's more than 1.
Exactly. Yeah, take a number like 16, which is 4 times 4, 2, 2, 2, 2. Now, we already counted one of his 2s because we took a 2 from every even number when we came up with the 52s, right? But he's got 3 more to spare to contribute to the pile. And there's a bunch of other numbers like him, right? We could easily demonstrate it. For sure, it is true. Good reasoning. Good? That makes sense? It's way more than 62s in there. And the same thought's helpful for all of us. All right, let's try this one. 2 to the n into 14 factorial. So they want us to find the largest n that'll work. So that 2 to the n will go into 14 factorial. So how am I going to do that? Here, I'll make it long division like that. I should probably break apart that 14 factorial, huh? Into his pieces. So let's do that. I'm going to come over here and go 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's 14 factorial. And what I'm wondering is how many 2s are in there? You tracking with me? Because I'm wondering, can I put 2 to the, 6th here? 2 to the 5th here? What power can I put on that 2 and have it go in? That's what I'm wondering. So to figure that out, I got to figure out how many 2s are in there. No whistling in class, please. I'm just kidding. But I got to figure out how many 2s are in there, right? So let's take a look. 14 is 2 times 7. There's a 2. 12, I'm just going to break apart the numbers that have 2s in them and find out the total amount of 2s. 4 times 3, there's 2 more 2s because the 4 breaks down to 2 2s. How about the 10? 2 times 5. How about the 8? That's 2 times 4, which is 2, 2. So there's 3 2s. How about the 6? 2 times 3. The 4, 2 times 2. And then the last 2 all by itself. Are you tracking with me? I just broke down all the numbers in the 14 factorial, from 14 all the way down to 1. I broke them all apart to find out all the 2s in there. So how many 2s do we have all together? 1, 2, 3. I'm just going to count. 3, 4, 5, 6, 7, 8, 9, 10, 11 2s. 11 2s are in there. So what's the biggest power I could put on this end? It's 11, isn't it? 2 to the 11th will go in there, won't it? Because there's 11 2s. But 2 to the 12th wouldn't go in. Because there's not 12 2s in there. So the largest n you can put is 11. Does that make sense how we figured that out? Want to try part B there? 2b. 6 to the n going into 20 factorial. Find the largest n. Yes, let me give you a second. Let me give you a little bit of time to think about that.
And in the time of, let's see. Okay, so, or you can,
Okay.
there's the 2 and the 3 that you can multiply again, and the other is 6.
Gotcha.
Yeah.
So you're pointing out, how do you say your first name? One more time. My Chong? My is saying, well, 6 is made out of 2 times 3. 6, breaking it down. So we want to break all the numbers down. 2 times 3. So anytime a 2 and a 3 get together, they're going to make a 6. If I can put extra words, I think, to what's in your mind. Yeah. Okay, so my, where did you go from there? So, this is 2 times 3. So how do we know how many there are?
You would have to factor all of them out to the prime.
Oh, so we got to break all these things down?
Yeah.
This is getting painful. Like every number?
That's what I did.
And are you done with that already?
Yeah.
Wow, and then you counted everything up?
Yeah, I got, and then it's
8 of them. Now, what do you mean you got 8? Like, what 8 things did you find?
8 of 6.
But how you didn't?
So there's.
You didn't actually see 6s over there. You didn't see 8 6s. What did you see?
There's at least 8 30s and then at least 8 2.
Okay, so in the mess, and you can tell I don't want to do it, so I'm not going to. But in the mess, I did fast and hard work over here. In the mess of breaking all these numbers down, she's saying she found 8 2s and 8 3s. Right? That's what.
Then there was extra 2s, but then.
There were more than that 2s.
Yeah, but then you have to have equal pair of 2 and 3 to make that 6.
So she's saying, look, what's going to make a 6 is a 2 and a 3 getting together. In any way, shape, or form that a 2 and a 3 get together, they make 6. So she counted all the stuff over here and all the stuff over there and found 8 3s and a whole bunch more than that 2s and said, oh, that's 8 2 3 pairs that can get together. 8 6s. What do you think about that? Is that true logic? Is it true that anytime? So certainly what was being said before was true. I mean, anytime we have a whole 6, that's going to work, right? That's what was being said at first. Is anytime we have a whole 6, 6, 12, 18, right? 18, 12, 6. Those all have a 6 in them. 6, 12, 18. So that's going to be a 6. But now we're pushing that to a new level saying, you can directly have a 6, but you can also get a 6 anytime you got a 2 and a 3. That's a 6. So if that's the case, then what would be the quick way? So if you're thinking that way, okay, anytime I find a 2 and a 3 over here, I've got a 6. That's going to make a 6. What would be the quickest way to count? Because this looks like a lot of work. What's the quickest way to count all the 2, 3 combos that are going to get together? Because that'll make a 6, right? Every time they do. Are there going to be more 2s? Well, what is there going to be less of? It's going to be way less 3s. Right? You tracking with me? Because there's a whole bunch of every other number has a 2, as we talked about. There's tons of 2s over there, right? So, but there's much less 3s. So if we want to know how many are getting together, we count what there's less of. It's like a junior high dance. When there's only a few girls and a lot of boys, or vice versa, right? The number of couples that dance is going to be limited by the lower group, right? That's kind of what we're doing with the 2s and the 3s here. Whoever there's less of tells us how many are going to dance together, the little 2s and the 3s, right? You tracking with me? Because anytime a 2 and a 3 get together, they make 6. So I want to look over here and find out how many ways I can make a 6 out of all these pieces. The easier thing to do would to count how many 3s there are, because there's going to be a lot less 3s. So how many 3? Can we do that fairly easily? Let's start here. There's a 3. Where's the next 3 going to be? In what number? In the 6. 2 times 3. There's a 3. Where do we next find 3s? 9. 3 times 3. There's 2 of them. So far we've got 1, 2, 3, 4 threes. Let's keep going. What's the next number? Going up the line here. 12. That's 4 times 3. I don't care about the rest of the breakdown. I'm just looking for threes right now, right? Because that's going to tell me how many 2, 3 combos get together. So what's the next number that's going to have 3 go into it? 15. 3 times 5. What's next? 18. That's, now careful with that one. That's well, you might start and go, well, it's just 3 times 6. So there's 1 3. But 6 has another one. Are there any more threes? The next number would be 21. That's not there, huh? So how many total threes do we have? 1, 2, 3, 4, 5, 6, 7. Oh, and I forgot this guy. 8. I forgot the 3 himself, huh? So 1, 2, 3, 4, 5, 6, 7, 8. 8 threes. Plenty of 2s to dance with those 3s. It's going to be 8 2, 3 pairs that get together. So the largest power is 8, isn't it? Does that make sense how we did that? It was good thinking. Very good thinking. Questions? So you're getting the idea about primes, right? Primes are the building blocks of all the other numbers. So if you want to know something about a number, you look at its primes. Anytime those primes get together, that's when they make whatever the number is. Makes sense there? Like good? 36 to go into in factorial. We want 36 to go into in factorial. We're supposed to find in, so that's the case. So what's in a 36 out there? That's where we're going to start, right? It's all about primes. So what's in a 36? 4 times 9, 2, 2, 3, 3. So basically 2 squared, 3 squared. There's the guts of a 36. 2 squared, 3 squared. So the question is, what in is going to have that stuff? Right? If it's going to divide in, what in is going to have that stuff? Like what if I make in, I don't know, 4 factorial? Will that work? What's in a 4 factorial? 4, 3, 2, 1. Does that have 2 2s and 2 3s? No, it's got the 2 2s. In fact, got 3 2s, doesn't it? It's got plenty. It seems like we always have plenty of 2s, don't we? But you don't have 2 3s. There's only 1 3 in 4 factorial. So that's not going to work. Got to go a little higher. All right, how about 5 factorial? Does that have 2 2s and 2 3s in it?
No.
What's it missing?
3.
Yeah, it's only got a single 3, huh?
6.
Yeah, let's go to 6 factorial then. So next would come 6 factorial. So that's 6 times 5 times 4 times 3 times 2 times 1. Does that have 2 2s and 2 3s? Yeah. Plenty of 2s. Where's the 2 3s? There's one of them there and one of them there, huh? And lots of 2s. So what's the smallest number that works? 6. Now, why do we say smallest? Why don't we just say, what's the number that works? 6 factorial. Why don't we say smallest? Because bigger numbers would work also. Once 6 factorial is working, if somebody says, hey, would 36 also go into 7 factorial? Well, of course. Because 7 factorial is 7, and then all the stuff that 6 factorial had. So if 6 factorial had the stuff, 7 factorial and anyone bigger will certainly have it too. Make sense? See why we're saying smallest? What's the first n that'll work? 6. 6 factorial has all the stuff you need. Can you try B there? 3B on your own. See if you can come up. So break down that 80. Right? Break down that 80. Find out all the pieces in an 80. So does 80 go into, or for what end does it go? So break down the 80, 8 times 10, 2 times 4, 2, 2, 2, 5. So 1, 2, 3, 4 2s and a 5. 4 2s and a 5. So what do you think? You're trying it out, so just give it a try there. You can just start guessing. Guessing is a good thing to do in math. Guess and check, and if it's wrong, guess again. How about I start at 4 factorial again? 4, 3, 2, 1. Does this stuff have, what is it, 4 2s and a 5? In 4 factorial, do we find 4 2s and a 5? No. What's missing? Yeah, we don't even have a 5 yet. So we better go to 5 factorial at the least. 5, 4, 3, 2, 1. Does that have everything? What's it missing? Yeah, how many 2s does it have? How many 2s in the 4? 2 there, and 1 there. 3 2s and a 5. We need 4 2s and a 5. So we got to go up a little bit higher. How about 6 factorial? 6, 5, 4, 3, 2, 1. Does that have everything we need? It's got the 5. Does it have the 4 2s? It's got 1, 2, 3, 4 2s. 4 2s and a 5. So what's the first number that works? The smallest number that works? 6. Was that the same thing as last time? Yeah. It's just a coincidence. 6 factorial is again the first one that works. Is this making sense? Thinking about primes? All right. Thank you for students over the years, so let me help. Basically, it's all about plugging in numbers and trying stuff out. So let's go. So they're saying if A divides B and A divides C, then A divides B plus C. Is that a true idea or a false idea? True theorem, it would be called in math, or a false theorem. Is that right or false? True or false? Well, okay. So here, let me write it. If, a little bigger for you, if A, that means divides into, right? Remember those straight lines means long divides into evenly, right? If A goes into B evenly, and A goes into C evenly, then A goes into B plus C. Is that true? So let's just try guessing at some numbers. So how about if I make A 2, B 3, and C 4? What if I do that? What if I say, okay, A is going to be 2, B is going to be 3. You know, A is the same thing, right? Whatever A is, it is in both cases. Let's say A is 2, B is 3, and here's A 2 again, and C is 4. I've made up some numbers, okay? Then it says A will go into B plus C. So is that true? What's A? 2. Does that go into B plus C? What's B plus C? 3 plus 4? 7. Does 2 go into 7 evenly? No. So maybe this is false. Are you concerned about the example I did? I can see the concern in your face. Talk to me.
Because 2 doesn't go into 3 evenly. That's an if then. So if it doesn't work in the first part, we would not in the second part.
Paige.
Yeah.
Excellent thinking. Everybody hear what Paige said? Right. If somebody says if then, and you don't meet their if, you haven't even addressed their question. Like what if I said, hey, if it's a dog, then it's black. Now that's not true, of course. Not all dogs are black. But if somebody tried to prove me wrong, I am wrong. But there's a way to not correctly prove me wrong. How would they prove me wrong? If I said, hey, if it's a dog, then it's black. You would prove I'm wrong by finding something that is a dog and it's not black. Huh? You got to meet my if, huh? If I said, if it's a dog, then it's black. I'm wrong. The way you would prove me wrong is finding a dog, meeting my if. It's not black. Somebody said, well, look, what are you talking about, Mr. Hare? Look at that cat over there. That cat's not black. What would you say? You'd go, I didn't say anything about cats. I said, if it's a dog, it's black. Right? When somebody makes an if then, you've got to meet their if, huh? So they said, if A goes into B and A goes into C, then it'll do this. I didn't meet their if. 2 doesn't go into 3. That's a cat. They didn't say anything about cats. They said, if you got a number that goes into a number, and that one, then it'll go into those two atoms. So I have not disproven them yet. I pointed out a cat that's not black. That doesn't disprove their statement. Good reasoning page. So I got to fix this. I can't. You got to meet their if. So how can I change the example so that their if is met, and then I'll check their conclusion? I got to find a dog. Because they said if it's a dog, right? So how about what's a B I could pick? 4, 6, 8, 10, 12, anything like that. And what's a C I could pick? 6. How about, yeah. Just pick a couple of ones that A does go. Now I'm looking at a dog, right? Because A does go into that, and A goes into both, right? I've met their if. So is the conclusion true? Does 2 go into, what do they add, a 10? So therefore it's always true. Well, no, that's not quite right. But this one is true, and we're out of time. We'll stop there and do more next.